Okay, so we'll start in this video with problem 1631. And that says, provide the reagents necessary for the following synthesis. And that synthesis is that we start with this compound with the cyclohexyl group and this alcohol, and we need to make this compound with the cyclohexyl group, this ethyl group, this propyl group, and the alcohol. So this can be done with Grignard reactions. The first thing we need to do to make this work with a Grignard reaction is to convert this alcohol to carbonyl. So that can be done using PCC. Once we have the carbonyl, we can react it with the first of our Grignard reagents. Let's use the ethyl group first. So ethyl magnesium bromide, followed by an aqueous acidic workup. We'll convert the carbonyl back to an alcohol and add an ethyl group to that carbonyl carbon. So now to add the propyl group, we need to convert that alcohol back to a carbonyl. And then we can add the propyl group using propyl magnesium bromide, followed by an aqueous acidic workup. So now we have our cyclohexyl group, our ethyl group, our propyl group, and our alcohol. So this is the same product as what we're trying to produce here. So that's how we could go about doing this this problem. We'll go ahead and do problem 1632. And that's in two parts. So 1632A, synthesize phenylpropyl ketone from benzene and any other needed reagents. Okay, so first, phenylpropyl ketone has this structure with the phenyl group on one side of the ketone and a propyl group on the other side of the ketone. So to produce phenylpropyl ketone from benzene, this can be done with a Friedel-Crafts acylation. So start with benzene. You can use this propyl acid chloride with aluminum trichloride. Now we don't have to use an acyl chloride with Friedel-Crafts acylations. Apparently we can also use anhydrides. So rather than using this reagent, we could achieve the same result using this propyl or dipropyl anhydride So that's another way of doing the Friedel-Crafts acylation, that we end up with the same product, but it doesn't require the use of an acyl chloride, and so it doesn't require the use of thionyl chloride in order to produce that acyl chloride. So 1632 Part B. Give two methods for transforming phenylpropyl ketone into butylbenzene. Alright, so what we want to do is convert this phenylpropyl ketone that we made in Part A to this butylbenzene, which we can do simply by getting rid of this carbonyl. And so there are multiple methods that we can do, we can use to achieve this. One could be a Clemmensen reduction, which uses zinc amalgam with hydrochloric acid. Another is the Wolff-Kishner reduction. We use hydrazine and hydroxide and heat. And we also have the Mozingo reduction. Where we start with this dithiol catalytic acid, and then react that product with Raney nickel with hydrogen gas. And all three of these reduction methods will get rid of that carbonyl and convert our phenylpropyl ketone into butylbenzene. Alternatively, we could reduce this carbonyl to an alcohol, and then we could use acid catalyzed dehydration to get rid of that alcohol and form a double bond, and then we could reduce that double bond using hydrogenation. So to outline that method, let's use sodium borohydride in methanol. To produce the alcohol. Then concentrated sulfuric acid with heat. To dehydrate that alcohol, and then you can do catalytic hydrogenation, hydrogen gas on platinum, to convert that double bond to a single bond. So it's a little more complicated way, more steps are involved in order to produce the butylbenzene. But you can see that there are several methods for achieving this this reaction. So we'll go ahead and stop this video with these questions 1631 and 1632, and move on to 1633 in the next video.